You are awesome. Don't forget that. You're doing great work. Keep it up.
Hi everyone, I'm Michelle and I'm the product manager at Deepgram, and today I'll share more about building conversational AI agents with voice. So a little bit more about me. I'm Michelle and I'm a senior product manager at Deepgram, leading our new text-to-speech product Aura. Deepgram has been a leader in the transcription space in the last few years, and we are launching a new product with text-to-speech. So these are some of the clients that Deepgram is working with, including Spotify, NASA, Twilio, etc. And the reason why we're building text-to-speech after our transcription product is that we think that with the rise of conversational AI agents in the future, there's a lot we can do with voice. And when we have both text-to-speech and speech-to-text, we can greatly improve the conversational experience as we move forward. So what is a conversational AI voice agent? You can imagine that on the right there is an LLM. You have a customer that dials through, let's say, the phone, and then it will have a transcription of the voice into text, maybe processed and sent to an LLM, and then it will generate some responses that will then turn into speech that's delivered back to the customer. So some typical use cases will be when you're calling on the phone for appointment booking, customer support inquiry, outbound sales, interviews, etc. And oftentimes with a conversational AI agent, it buys you time to, for example, there are many use cases where a user may call to a company for customer support. There may be a triage phase where the user will first talk to an AI agent first to collect all the information before it's passed on to a human agent. So this can also evolve in the future, but there are a lot of use cases that meets a voice conversational AI. So what's a good conversational voice AI experience? After talking to many users and diving into the space, some of the things I'll share will be some key tips with building conversational AI agents. The first one is latency, which is very important. There is a couple research out there that basically evaluates how long if a person is talking to, let's say, a robotic agent or another person, what's the maximum latency that the person can tolerate until it gets a little bit off or a little bit slow. And the research results show that ideally in a conversational two-person conversation, a 300 milliseconds latency is the benchmark we can look into. This is still a little bit far off if you include an LLM, as many of us have tried out with LLM with the latency, but this is where humans will feel a difference, and this is where we're aiming at. So some other tips that I'll share in this presentation, other than latency, is some of the things that we need to figure out throughout the entire journey. The first problem is, let's say the human talks on the phone. It is then transcribed. But how do we know when the human stops talking? Because that's also a very nuanced question. It can depend on, for example, the tone of the person, the context, the last sentence that the user is talking about. And so as a builders of conversational AI agents, you'll need to look into things like endpointing. This is what we would typically call when we are figuring out how to solve this problem. So Deepgram speech to text also offers an endpointing, and you can use that as part of your transcription to know whether the person stops talking. The third thing that is important in a conversational AI experience is voice quality. And in the research world, we call this prosody, which includes the naturalness in speech, including rhythm, pitch, intonation, and pauses. And some of the things to note when you're building conversational AI agents is that there are different types of voices out there with text to speech from different vendors. Some may be optimized for example, movie narration. Some may be optimized for reading a news article. Some may be optimized for an ad in a video. For Deepgram, we are looking into voice qualities that can make a conversation sound like a conversation. So it sounds as if you're talking to a person who's themselves talking about your daily life questions, typical conversations. And so we care a lot about this aspect of the voice quality as we design a product. When you are thinking through building your own voice AI agent, it may be helpful to figure out what is the type of voice that you're looking for. For example, what are the voice branding guidelines you're looking into? What are some reference voices that you find is helpful? What are the characteristics in the tone, in the emotion, in the accent, in different areas? What's the demographic that you're looking for? That will be very helpful as you nail down a voice that you would like to use in your conversational AI. So the fourth thing, as we are branching off from naturalness, is filler words. So a little bit different from, let's say, a text-to-speech reading from a news article is that in human conversations, oftentimes what makes human conversations natural is things like I'm also having a lot of ums right now, and the breaths, like thinking time and all of that in appropriate locations. So what we've seen from our users playing around with conversational AI agents is that they would ask the LLM to speak in as if they are speaking a conversation. You can also add pauses. So, for example, three dots, like dot, 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 and you can see some vendors having breaths, having like pauses, and all of that. And you can also try figuring out filler words as well. So, this is also another aspect. Um, and then, so working with speech to text with LLMs. With the requirements that I mentioned just now with the last few slides, some of the tips are with latency is that, as we all know, LLMs are auto-recursive, outputting word by word. And so how should we think about chunking these words and sentences together and send this to an LLM? Some vendors may offer real-time input streaming. You can also figure out yourself, depending on your conversational data, on some logic that you'd like to work on to chunk them together to optimize for the latency and also the quality of the voice. Because if you're just sending out per word, there are cases that maybe the output could be more chopped up as well. It also depends on the model. The second is with quality. And so outputs by default don't sound like a conversation. And so I mentioned in the past on some things that I've seen users working on is playing around with the prompt and output and pauses and everything so that it sounds more natural when you're using text to speech. So lastly, just going to mention that we are launching a new text-to-speech product called Aura. You can check out this Aura preview announcement. I can share the link with the team to share it out. That we're targeting low latency, under 250 milliseconds, conversational voice, and a comparable cost as well. So if you're interested in a preview, feel free to email me. But yeah, thank you.
Nice. Michelle, I hadn't quite thought about just how complex, how difficult a task it is to do speech. I mean, and to do it properly. I mean, it sounds like there's just a vast jungle of complexity there. So thank you for walking us through at least some of it. There's a couple of questions here from the audience. I'll just go through them very quickly. To know when a human stops talking, isn't that, can't you just use like isn't it a probabilistic task for an LLM? Isn't that sufficient to figure that out? Like what makes that task difficult?
So I think it's to do with an appropriate, like let's say a user is talking, when it's and it also isn't just an LLM task. It depends on the user's tone. So let's say you're detecting if a human saying and then like thinking or like it's a little bit like it wants to continue. It
Yeah.
actually is less than, it's not only a text problem. Yeah.
Yeah. Yeah. One more thing here. How about slang? Is there a way to incorporate slang into this? Do you have like different
Slang.
yeah, like how do you teach the LLM or like just like the agent here to be speaking at like a more colloquial like language? Like on one hand you already said that the text that let's say like traditional LLMs are producing, it's not like spoken word, right? So you have to chunk it, you have to ask it to be much more specific in how it structures its output. Are there other things you can do to just like change the actual like words that are used?
Yes, you can change the words that are used. You can, but um, I think the technology is still developing on, okay, based on an LLM output, how can you actually turn this conversational? There are prompts that you can do, but
Mm.
it also can start from, for slangs, like it has to, it sounds real when it's in the accent together with the slang. And so
Yeah.
there's a lot that also from the data set side of things that you can work on as well.
Awesome. Michelle, thank you very much. Drop us the link. Stay in the chat, please. And keep up the good work. Thanks for
Thank you.
coming.